Constraint schemas are a method of applying additional constraints to what XML schema does. And there's a lot of different ways to do it. The most common is doing cardinality constraints in the subset schema. Now in the old days, what you did was you generated a subset schema, you went in by hand, and you changed the min-occurs and max-occurs to meet whatever your needs were. Now that functionality is well supported in the SSGT itself. So the concept of having a separate constraint schema in terms of cardinality kind of goes away because it's really just part of your subset. You do that all in the SSGT and it handles it really well. There's another concept of constraint schema, and that is a non-NIEM conformant schema. So basically you take the NIEM schemas and you do non-conformant things to it, and then you do parallel validation, validating an instance document against both the NIEM conformant versions of the subset and any non-NIEM conformant schema you have to check additional things, and you basically have to pass validation against both schemas. Other methods of constraining beyond what XML schema can do include using kind of higher level constraint languages like schematron. As schema controls what an instance document looks like, things like schematron can help control what schema itself looks like and put better constraints, tighter constraints on the resulting instance documents than schema alone can do. Finally, you can use external coding, database constraints, and other tool constraints to help constrain your schemas. A lot of times you want to constrain a certain kind of information. Sometimes it's easier to do it at the source, say from the database, than to try to do it in XML schema. So there's a lot of different ways to constrain stuff, but typically and classically when we talk about constraint schemas, we're talking about either adding cardinality to the subset, which is all now done in the SSGT, or about non-NIEM conformant schemas and a parallel validation step. Now I mentioned schematron on the previous slide, but schematron isn't the official way of doing NIEM constraints. It's certainly a method and you can do a lot of really cool things. And if you want to know more about it, I know people who are very, very good at schematron. I myself aren't, but I know folks who are really good at it. So you can do a lot with schematron, and it may play a role in future NIEM constraint mechanisms. So XML schema itself is really limited in its ability to enforce business rules. And what we want to do is build a new specification, which is in development, to help people have tighter constraints on their data, more flexible constraints as well, just basically be able to do more with constraining the contents of exchanges. Now this new specification will probably involve schematron. It'll also be focused on letting you be able to document your method of enforcing business rules. Rather than tell you you have to do things in a certain way, what we want to do is have a mechanism for you to document how you're enforcing business rules so that other people can do the same thing. So this is very different from saying this is how you will constrain things in the NIEM in the future, and more about giving you tools and abilities to constrain things yourself, but document that so that other people know what's going on. So let's finish out with a little bit on validation itself. The way XML schema validation works is this. You've got your exchange schema, and basically you throw the instance document at a validator and say you validated against this exchange schema. What happens then is the exchange schema, basically via your validator, pulls in the extension schemas that you've referenced in it, and potentially some direct NIEM subsets too, particularly if your root elements type is defined in the exchange schema. But it brings in the extension schema. The extension schema then pulls in the subsets that you're using, or the majority of them. Everything in the subset schema that references something out of the NIEM will have a namespace declaration in the top. It has to, or it won't validate. And so that then will import in all the subset schemas you're using with all the elements. Now the only ones it won't pull in directly are if you have one subset for one domain that uses something from another domain that you didn't directly pull into your extension. So if I'm grabbing something from Cyphus and that thing in Cyphus is dependent on something in Justice, even if my extension doesn't pull anything from Justice, I'll still get Justice because it'll get pulled in because Cyphus is pulling it in because Cyphus uses it to do the thing I'm asking Cyphus to give me. Whew. Then once all of that is pulled in, all those schemas are all pulled in and held in memory basically, the schema validator now understands all the rules for your schema. And now the instance document can be compared and validated against that vast rule set that it's just built. And you'll either get a pass, everything is great, or else you'll get a fail and potentially a whole long list of error messages saying what's failed. A final word and some considerations on validation. Non-conformant constraint schemas that don't conform to the NIEM, require a parallel validation step. You validate against the non-conformant schema as well as against the NIEM conformant schema. So basically you require twice as much validation. Other methods of constraining to business rules, like Schematron, have their own methods of validation. So you can use other ways to constrain your instance document to certain business rules, and each of those other methods will have their own method of validating whether or not an instance document conforms to the business rules that are being defined. That validation may precede schema validation, or it may follow XML schema validation, or it may take the place of XML schema validation. So there's a lot of different ways that can work. Validation may be done in real time, whereas every time you get a payload document with an exchange in it, you validate it against schemas. Or validation may be limited to testing, using a certification process. In other words, you may have a testing phase where some other body sends you information and you validate it real time until you're reasonably sure that they've got their act together and they're going to send you valid information, in which case then you turn off the real-time validation and you only deal with them in case you start getting errors. And maybe you give them a certification and then they can send you stuff and you won't validate it, but if they start screwing up and sending you stuff that isn't valid anymore, then you yank their certification and then retest them until they get their act together again. So there's a lot of different ways to do validation of your instance document to make sure it conforms to various business rules. Finally, a little licensing information about these materials. These materials are licensed under a Creative Commons license. What that means is that you can take these materials and distribute them yourself, or you can use them as a base for making derivative works. There are, however, two limitations involved. Limitation number one is that if you do distribute these works, you have to distribute them under a license identical to the one I'm showing you right now. And if you want more information about it, there's a URL on the screen. So if you distribute the works, you have to keep the Creative Commons license on them. The reason for that is that it ensures that other people can then take your work and do more stuff with it. These materials go back well over a decade in their original form, and they have been modified and enhanced throughout the years because this license protects the ability to do that. So it's very important. The second part of it is attribution. You need to give credit to the original authors of the work that you're using. So in this case, we're going to give credit to the various works that this work is based upon, and that's in the next slide. This particular work was funded by a grant from OJJDP, the Office of Juvenile Justice and Delinquency Prevention. They're based upon other prior works, partially work done by the Department of Homeland Security under their own grant, and partially under work done over the years by the IJIS Institute, the National Center for State Courts, and the Georgia Tech Research Institute. These materials are a combination of all those prior works modified and enhanced for the Children, Youth, and Family Services community.